It's never been easier to create an IoT solution. IoT initiatives that start rapidly over pizza and pop often suffer from their successes and are expanded to cater for demands that they were never built to manage. These solutions often grow into monsters, prone to fail. Early recognition of the need for highly scalable IoT will help you avoid the pitfalls of your success.
Welcome to today's webcast titled Scale for Success, How to Bring IoT Projects from Concept to Mass Deployment Efficiently and Reliably. Today's program will be presented by Robin Duke-Woolley, CEO of Beecham Research, and Philip Hooker, Vice President for Strategic Programs at Software AG. As we move through today's program, we invite you to submit any questions that you have. The question box is located on the webcast dashboard in the drop-down menu. Type your question into that box and hit submit when you're ready. Now, just to kick us off and guess where you're all at as an audience, we wanted to run a little litmus test. Now, scale is a massive topic for everyone, and to understand where you are in your IoT project, we have a short poll which is about to appear on your screens.
Excellent.
Right.
So,
okay, good.
So Robin, so it looks like the majority of our audience at the moment are in this research or proof of concept phase, which is pretty interesting.
That's very interesting, yeah, and makes it all very relevant actually to what we're going to be talking about. And then a lot in the first stage deployment and pilot stage as well. In fact, the majority. And we then got a few, 15%, who are at the third stage deployment. So hopefully we'll know what we're talking about and have already experienced what we're going to talk about.
Brilliant. So it makes it kind of very relevant, the stuff we're talking about. So maybe kind of let's start with the presentations.
Indeed, yeah, absolutely. Right, okay, so we'll start with my my slide. So if you could take us to the first slide, that's great. So this is a scale for success, bringing IoT projects from concept to mass deployment. So picking up really where the video that you've just watched left off. So go to the first slide, please, Phil. So just to bring to your attention that Beecham Research produced a report on this, Getting to Mass IoT Deployment Challenges and Opportunities. This is a free report that's available for, as I say, free download at mass-iot.com. And it includes all the main connectivity technologies. And the key questions that we're asking in the report is, why do we need to be looking at mass IoT now? And what are the issues in scaling IoT solutions from small numbers up to a few hundred to hundreds of thousands of devices? So can we have the next slide? So we conducted a number of surveys, and I've got some results from two surveys, Survey A and Survey B, that I'm just going to draw on. And then some interview results as well, just to pick out some key points before Phil then goes into more of the detail. So the first one, Survey A, marketing. The market is moving to massive IoT. So we asked users roughly how many IoT devices and/or terminals are currently connected in or through your business. And of significance is that we had 26% at over 10,000 units. Now, if we conducted this survey 3 years ago, we'd have had a very small number of those. It would be mainly down in the under 100s and 100 to 500. So there's been a significant change in the last few years about that. A related question is, how do you expect that to change in the next 24 months? And the key point to see is that 22%, we're reckoning of over 40% growth in their deployments, a further 18%, 20 to 40%, and 21% at 10 to 20%. So if you look at 10% plus, that's by far the majority of what's going on in deployments right now. Can we have the next slide, please? And then from Survey B, we were focusing more on the actual individual deployments. So what is the size of your initial IoT deployment and how large is it now? And it's fairly obvious that what we're getting to is growth. So in the initial deployments, 78% were under 500. Under 500 connections, and that's gone down to 47% in the larger stuff now. And at the other end, over 50,000 was 1% at the initial deployment, and up to 9% of the sample by the time of getting to now. So can we then move on to the next slide, please? So we're seeing quite a large move up the market, and of course this is what we would expect to happen with IoT. But the thing that we have a real concern about in our report, and what we're going to talk about, is what does that mean for users? This move from small deployments to much larger deployments. Now, Survey B here is how widespread those largest IoT deployments are. And although 37% are site-based or city-based, 27% are international. So, and what we would expect is that over time, more would move to the right on this. But clearly there is quite a strong movement that way anyway. International and national tend to be larger deployments. They've certainly got more issues in terms of connectivity and reliability requirements and so forth. So much more of a scaling issue is needed to look after those larger deployments, or more widespread deployments. Next slide, please. And at the same time, what we're seeing is a significant change in the types of IoT applications that are being supported on these solutions. So we have here, so the question is, what types of IoT applications is your business currently using or expecting to use within the next 24 months? And tracking movable assets, 58%, and remote monitoring of non-real time, 59%. But much more interestingly is remote monitoring and control in real time, 72%. And predictive maintenance for machines, 45%. So it's those two last categories that are growing substantially. And we're moving away from the simple use of IoT being remote monitoring in non-real time towards remote monitoring in real time, and then much more exacting, if you like, in terms of the types of data with like predictive maintenance and so forth. Much more timely information is required. And we're all experiencing that now, that IoT is moving much more to central types of operations rather than peripheral. And that's going on at the same time as the solutions are growing. So next slide, please. And at the same time, we're seeing substantial connectivity growth. This session is not really about connectivity, but as a sort of side point, it's useful to understand that although cellular connectivity in our surveys is clearly the leading type of connectivity, nevertheless, there are quite a lot of others, and these are shown as all growing. Of real significance is the growth in LoRaWAN, So again, if we'd done this survey 3 years ago, LoRaWAN at over 50% of connections for a particular deployment would have been a very low figure, but at 22%, it's growing quite quickly. So we're seeing a multiplicity of different connectivity types as well, and obviously that has to all be managed at the same time. So next slide, please. Now we get on to some of the outputs from the expert interviews that we did for this study. And the first question is what issues do you see in deploying and supporting these large deployments? And a number of responses. I'll read through these ones. Probably the number one challenge is businesses taking on more than they can manage themselves. That was an observation from one of our expert interviewees. Number two is the vast number of IoT platforms at a proof of concept POC level. Anyone in the world can have a POC for a long time, not earning money. The ability to scale that is by creating production systems that operate continuously and can grow flexibly. Now, you would have seen in the video that started off this session, the idea that moving from a very small deployment to a large one isn't a case of just increasing the number of connections on that solution, because it might not be a scalable solution. It might be all sorts of issues creeping in once you start to get larger, and that's this point in number two, that when these systems were devised, they were effectively proof of concepts or early deployment type solutions, which had a different sort of set of requirements to them, which Phil is going to explain in a bit more detail. But now they need to grow, and they have much different requirements in the marketplace. We need to understand the different objectives that are required for larger systems compared with smaller systems. And then the third point here is compliance with local regulations, security rules, how to comply with regulations in Europe and in US, and that means facing multiple integrations, and then that multiplies the cost of integration, but it also increases the complexity of integration, because you have all of these different variations that you need to take into account. And the next slide, please. So then, what are the challenges you foresee with mass deployments? And then first point made was that first, when you do a very large deployment, for sure you will have problems. Looking at the defect rate, if you have a smaller deployment, you'll likely have several defects. If you have a large deployment, the effects multiply both at the start and ongoing. And that's a key point to also bear in mind, that the complexity in dealing with faults increases at the same time exponentially as you get to larger systems. So that's another reason why you have to plan a large deployment in a different way to a small deployment. The big problem in the IoT world and the mass IoT deployment, you know for sure that none of your products will be there for 10 years. We are really focused on making sure that you have connectivity products that have a lifetime that matches the customer's expectations. Those systems are going to be out there for a long time, and they're going to be under increasing pressure. So how can they be built to make sure that they cater for those requirements? And then the existing devices will have to be retrofitted and upgraded. And that's a key point that I'm going to cover in the next slide as well. So can I have the next slide, please? Okay, so the next question leading on from that is, to what extent do you see over-the-air updates as significant for these activities? And a general response to this was, it is a must-have. It is part of the security approach and strategy. And then the next point, it is an essential requirement to keep all elements of the networks healthy and secure. There is really no way of controlling and managing large network deployments, large IoT deployments, without having over-the-air updates and remote updates. And then, do you see the need or opportunity to use AI and ML to assist with these activities? And three different responses here. AI is at the heart of the solution. The output of the different spectra from our cameras is constantly monitored by AI. So that's a particular application that uses cameras. AI is essential for managing IoT security in mass IoT deployments. And the next one is along the same sort of lines. Complex systems with many participating parties need some level of AI for basic functions and access alone. AI can help greatly to communicate the outcomes efficiently and to make things interactive. It plays a big part in improving the services and capturing the client's experience. So there you have three different areas where AI is going to become increasingly important. We see in particular the need for AI associated with IoT security and the need to keep on top of attacks on networks and to be able to manage them at scale, because that's going to become an increasing risk as we go through time and as those solutions become more central to IoT deployments. So can I have the next slide, please? And this is really the key point that comes out of it. So from Survey B, we asked how much needs to change for large deployments. And we found that 48% of our respondents, a huge number, reckoned that a substantial change was required to their initial deployments to be able to scale to get to large deployments. 45% reckoned a minor change. Only 7% reckoned no change at all. And one wonders what they saw as being not required to change. But so those are the statistics, and I think it's fairly clear from that the majority of people who have been through this process, the vast majority that have been through this process, see major changes required in moving from small deployments to large deployments of IoT. Okay, and if you could move on to my last slide then, please. So this is something that is in the report, and it's just a diagram that shows key factors to consider for mass IoT. It comes under 4 headings. So streamlining IoT architecture, the market players themselves, and where they sit, the technologies and the key issues in those technologies, and then the economic and regulatory imperatives. So there are 4 streams, if you like, of key factors to consider for mass IoT. So that's my set of introductory slides. I'm now going to hand over to Phil, who's going to give us much more of the detail now. So over to you, Phil.
Excellent. Thank you, Robin. So efficiently transforming early IoT concepts into reliable value-generating mass deployments is the goal of most initiatives. But there are many challenges to achieving this, as Robin's actually indicated already. So my name is Philip Hooker, VP of Strategic Programs, and I'd like to show you how efficiently managing complexity can accelerate your large-scale deployments. And perhaps the best way to do this is to actually understand what a large-scale deployment is. It's actually by seeing one in action. So Hilti is a multinational company that manufactures professional products for construction, building maintenance, and manufacturing industries. They realized that tool tracking and asset management were critical issues for their customers and were needed to deliver transparency on tools, spend, and job sites.
What would be your ideal tool park management solution? Having full transparency of your tool park 24/7. Knowing if and when your tools needed servicing by simply scanning them. Having health and safety information whenever you needed it. Inventory checks that take seconds, not days. Instant communication between the office and job site. Running cost reports without additional software. A solution that combines tasks into one digital platform. Asset and inventory management. Tool maintenance. Health and safety. Job site costs. Hilti's leading software solution for the construction industry. optimized for both job site and office use. On track, Generation 3.
Great. So Hilti has millions of cordless power tools connected using OnTrack. Embedded Bluetooth chips, Bluetooth tags, and Neuron connected batteries transmit the tool usage, utilization, and location data to their cloud platform using local hubs and smartphones. This helps their customers to take better informed decisions, increasing productivity and minimizing downtime, automating testing, maintenance, and verification scheduling, and monitoring the usage of consumables for cost allocation and improved estimating. It's available for all Hilti and third-party products. When we think about IoT solutions deployed at large scale, we often just consider the number of connected devices. But there is more than just one dimension, as Robin indicated before. A second dimension is the data that each device sends that is processed, whether that be sensor measurements, events, or alarms. It is this combination of these two metrics, and potentially others, that give us an indication of the scale of an IoT deployment for a particular use case, with each use case having a different scaling profile. Our previous cordless power tool use case connects and monitors millions of devices, with each device transmitting a small amount of data infrequently. We would consider this large scale. On the other hand, wind turbine monitoring requires the processing of megabytes of data per second for each of the thousands of connected wind turbines. We would also consider this to be large scale. Then we have industrial air compressors that are used in factories and hospitals, with each of tens of thousands of the machines sending large so usage and performance data many times a day. We might potentially also consider this to be large scale. So with each of these examples, a determinant of scale might be the depth to which the device data is actually being used in the business. This is significantly different from the early proofs of concept or proofs of value, which are delivered to a different set of objectives. The initial stages of an IoT initiative are focused on exploration, typically delivering a minimum viable product that delivers value in the fastest time possible. To achieve this, the most successful delivery approach is often to form a project team with diverse skills and leverage the team's previous experience with tools and technology. Little focus is paid on the longer-term aspects of reliability, scalability, and performance, potentially because the project team may not have the competence or experience in that area, but more often due to the fact that any time spent on longer-term thinking reduces the time available to build the initial solution. And with only a fraction of the initial concepts likely to evolve to scale, project teams consider this wasted effort. On the other hand, those IoT initiatives that have successfully scaled have embedded their data-driven insights into their business's operations, which means there's a necessity to ensure the accuracy, reliability, and timeliness of this data stream, and the continuous operation of the systems that deliver it. As the initiative is now a core capability of the business, its longer-term aspects are now needed to be managed as a strategic asset. Roadmaps created for its evolution, business continuity plans for its continuous delivery, essentially requiring it to be managed like a product. This means that a fundamental part of the IoT initiative becomes its ability to efficiently maintain itself to ensure its continuous operation at the lowest total cost of ownership. Device management is therefore key. These two states operate with significantly different methodologies and success criteria. How easily you evolve from one state to the next is primarily determined by how well you manage complexity. So, complexity is an interesting topic. Initially, as complexity increases, the value increases as the sophistication of the product improves. Then there's a tipping point where additional complexity becomes a burden to the delivery organization, which results in diminishing returns. Now, Cost and risk, on the other hand, follow a different path. Initial increases in complexity have a little impact on cost and risk. But with all the costs accumulating, increases in complexity create a cascade effect that results in an exponential growth of cost and risk. A typical minimum viable product or proof of concept would start at A, being rapidly created from readily available modules using current competencies and leveraging pre-integrated devices. IoT initiatives that are at breaking point, breaking at the seams, are at B, having grown to a level of complexity at which the cost and risk are greater than the value, essentially delivering negative returns. These are potentially using technologies and methodologies that are not suitable for their purpose. Our sweet spot then is C, or even earlier, with close to the highest amount of value being delivered with a manageable level of complexity. But how is complexity created in IoT solutions? One way to consider complexity in IoT is by using a simple index which reflects the size and variability of each of the common IoT solution components, here represented as device, edge, cloud, internal customer departments, and external customers. I've explicitly excluded connectivity in this simple index. So in our proof of concept, we might have 10 devices connected to one edge gateway. They use a single cloud, the project's focused on the product development, and the work is actually with one prime customer. For this, the aggregate complexity is low. So now we've moved to our pilot. We've engaged 5 customers and connected 100 devices to each of the 2 edge gateways at each customer. This now totals 1,000 devices. It's a full pilot, so we've actually engaged the field services department. Our complexity index for the pilot is substantially bigger than that before. So then, without any alteration of the approach, we're now in the first phase of our rollout. We're working with 10 customers across 2 regions and growing the total number of connected devices to 10,000, whilst maintaining 100 devices for each edge. For the second region, we had to create an instance on a local cloud provider to comply with the local data privacy regulations. And we have engaged the field services team for this region also. As you can see, the complexity we need to manage in an IoT solution grows substantially at this very realistic, realistic growth scenario. The approach to managing complexity has a significant impact on the full lifecycle cost for software development and maintenance. Although the development activities only represent 1/3 of the lifecycle cost, they define the approach to managing complexity in the maintenance activities, realized in the business architecture and processes, meaning that the cost structure for 2/3 of the costs is defined by teams focused on time to value rather than assuring continuous operation and minimizing the total cost of ownership. Considering some aspects of reliability, scalability, and performance at the early stages of even the smallest projects can have a significant impact on the IoT initiative's lifecycle cost and innovation potential. So, what if you could build your IoT services on a basic and generic but rock solid and scalable IoT platform that's fully pre-integrated and available on any cloud or any edge? And what if that IoT platform was pre-packaged and easily configurable applications to manage devices at scale, process the data streams, and generate industry relevant metrics? That IoT platform will both shorten time to value for enterprises in the early stages of their projects and deliver the automation necessary to efficiently manage large-scale deployments. And what if the provider of that platform also operated it for you, so you can maintain your focus on your IoT-based offerings, and also had a catalog of integrated partner devices and solutions, which speed your solution development? This is the buyer's advantage. Enterprises are then able to take immediate advantage of a strong foundation with out-of-the-box self-service tools to get started quickly and maintain their focus on their domain-specific competitive differentiation. And be reassured that the IoT platform has the reliability, scalability, and performance for any large-scale deployment that may arise in the future, all without the need of an army of developers. This allows enterprises to adopt a buy and build strategy. This strategy is fundamentally different from the alternative buy or build approaches, which have either resulted in competitive innovation being frustrated or the total cost of ownership exploding as projects scale. And to cap it all, the time to develop a solution is 40% faster, and the operating costs are 30% less than those alternative approaches. We believe that exploiting the potential of IoT should be simple and fast for all. Our Cumulocity IoT platform helps industrial manufacturers to transform into service companies offering as-a-service propositions by enabling their domain experts to rapidly deliver business outcomes using self-service tools. The platform's capabilities include device management, enterprise integration, and the full range of analytics, including condition monitoring, real-time stream analytics, machine learning, model management, and data lake integration. And is used by customers like Stanley Black & Decker, Eppendorf, and Lyrico, who adopt the buy and build strategy. It is fully distributed and can be deployed on cloud, core, and at the edge, with our recent open source ThinEdge.io initiative extending the management of analytics models, OT protocol adapters, and IoT apps out into resource-restricted IoT edge devices. For any large-scale deployment, device management is key, as I indicated before. Regardless how your project starts, the only thing that is certain is that the requirements will change during its lifetime. How you manage these changes determines how you minimize complexity. Bulk device onboarding is essential. With industrial lifetimes of over 10 years, as Robin also indicated, the only realistic mid to long-term scenario is brownfield with a heterogeneous device estate. To support this, your device management platform must be both device agnostic and require very low integration effort, with many pre-integrated devices. Comprehensive edge functionality is also essential from two perspectives. First, your edges must allow you to fully manage the configuration and potentially control your industrial equipment, not just monitor the measurements being generated. This is typically called child or leaf device support. Secondly, to future-proof your solution, it's important to consider delegated device management, where a cloud platform can request a downstream cloud or edge platform to perform the device management operation on the end device. With the inevitability of managing a heterogeneous device estate, we should recognize the need to manage various connection technologies. This could be through proactive choices like deploying an overlay low power WAN network, sensor network, to improve the insight from equipment on your industrial SCADA network, or reactive needs like augmenting devices using different technologies to provide a consistent customer experience. Connecting to industrial equipment isn't easy. Modern technologies like OPC-UA or IO-Link make it easier, but there's still a huge range of electrical and data standards in use today. Using a connectivity accelerator for industrial field buses like OPC-UA, Modbus, and Profibus not only reduces the time to connect the industrial equipment, but it also simplifies field service tasks by automating the connection of additional equipment of the same type. Self-service analytics-driven alarm management is the panacea of device management for large-scale deployments. It allows you to predict the occurrences of common faults and automate their resolution. This allows your technical support team to focus their efforts on the new or unusual faults and significantly improves overall service levels. Now, I'd like to quickly outline a couple of Cumulocity IoT customers with large-scale deployments. Our first customer is a global leading elevator, escalator, and moving walkway manufacturer, which transports over 1.5 billion people per day. Using Cumulocity IoT, they were able to reduce field service calls by over 35% through increased automation and reduced the effort necessary to perform software updates by 50% on hundreds of thousands of connected devices. Furthermore, Cumulocity IoT powers advanced device management and automation processes, including mass remote equipment commissioning and automated error correction, delivering revolutionary people flow. Our second customer is a medical technology provider that provides products and services across a range of areas that enhance the outcomes of patients and caregivers in over 100 countries. Using Cumulocity IoT, they were able to save over 1 million hours per year for caregivers and technical support who are using their hundreds of thousands of connected devices. That's a 94% service time saving on their smart beds alone. But that's not all. Through connecting the devices, they have allowed the caregivers to improve equipment utilization through full asset visibility and increase process automation, delivering smarter care. Thanks for listening. JP, back to you.
Thank you very much, Phil, and thank you very much for those insights. Now, just before we head into our fireside chat, we have a second poll for you. At this time, please select what you see as your biggest challenge to scaling your IoT deployment. We'll just give it a couple more seconds, and then we'll be able to show you the answers before we hand over back to yourself, Phil, and yourself, Robin, for our fireside chat.
Excellent. So it looks like we've got some really interesting results there. So
yeah, it's very diverse. But I think the interesting thing is management process optimization at 40% is the key one. There's a lot of need to change processes moving from small to large, and that optimization process is clearly key. I don't know, what's your thought?
Yeah, so I mean, I think your research, Robin, has been kind of brilliant. It's definitely kind of it's definitely clearly aligned to the kind of firmware, software updates, etc. But
Right.
I think, like you're saying, so that need to manage the process within the business is probably one sort of key one here. But perhaps actually goes across all the other lines overall. So firmware updates, how to manage that for the self-service, the field
Right.
services teams, etc., etc. So that makes a lot of sense. So really good insight. So good to get some feedback. So so if I maybe Robin, if I kind of go back to one of the couple of points you kind of raised in your conversation earlier.
Right.
So I like really like some of the insights you showed there. So it's brilliant. So one of the things that really got me is actually, I understand that the market's maturing, but it's actually good to see how that's quantified. So your report indicated that sort of 35% of the respondents thought that their largest IT deployment would actually increase in the next 3 years. And I was wondering, with that, that's a good stat in itself, but did you get a feeling of the reasons or themes behind what's driving that growth?
Oh yeah, very, very much. Before we go on, can I just remind people to put your questions in, because we'll get to a Q&A session at the end of this, and if you have any questions that you'd like to ask us, then we'll get to that straight after this small fireside chat that Phil and I are going to have. Yeah, I mean, the real point here is that IoT is moving from peripheral operations to central, if you like, and we're seeing companies moving from proof of concept, initial deployments, to much larger ones at the same time. And we're seeing edge deployments. So that's another conversation that you and I have had before, Phil, about increasing use of edge. So there's a lot of things going on that are increasing the need for IoT, if you like. So this expansion of deployments from small to large is a major change in the marketplace, which is why we need to look at this now, because as I said in my interview feedback, one of the quotes was the vast number of POCs out there, and what are people going to do with them? Because you can continue to not make money out of a POC for a very long time. And I was really struck by your video right at the beginning, where there's a guy sort of tearing his hair out because he started with a very small deployment, and suddenly it's gone completely AWOL, a monster, as it was saying in the video. So I think that is happening. It's probably been a long time in coming. I mean, I've been in this industry for longer than I'd care to remember, but it's at least 20 years. And in that initial period, there were a lot of very small deployments, and people were quite happy with those small deployments for quite a long time. But it's now radically changing, and people do need to think about what that means. So this figure that you picked out, 35% of respondents thought their largest IoT deployment would increase by 40% in the next 3 years. That's just indicative of what's going on in the marketplace. It's a huge change that's underway now. IoT is moving from, if you like, the early adopter phase to the main usage phase, if you like. It's crossing the chasm into the area of mass deployment, and then we have to take that into account. So I got a question for you, actually, on a much more detailed level, which is what does device and connectivity agnostic really mean? I mean, so you pay a lot of attention to that, and you are looking at different ways of managing these platforms and solutions. So, just I think if you can explain that a little bit more, that'd be very helpful. So, what does device and connectivity agnostic really mean?
Yeah. So it's a good question. So the I think what we found, I think speaking about the heritage of kind of IoT and M2M, Rob, is that there's been a lot of bespoke vertical solutions that have been created over the years that have typically taken an approach that the first device you connect or the first solution you have, then you sort of scale that. So what's been needed in the market from a Cumulocity perspective is to have an understanding of there may be other devices you're going to connect, there may be other use cases you're going to have, there may be other networks or connectivity technologies you need to manage at some point in its lifetime. So how can you create a solution that's easy to connect to, easy to manage, easy to evolve? So part of that is actually having a kind of a flexible IoT platform architecture allows you to do that. Another one's actually having a flexible device data model that allows you to connect different services. So whether that be from kind of small edge gateways up to kind of the directly connecting the control boards inside air compressors. So how do you connect? So obviously things like kind of common protocols using MQTT or lightweight M2M, plus also having sort of open source agents that could be deployed onto the device themselves, like thinedge.io, or having server-side agents that could be deployed in the platform to connect to on a LoRaWAN technologies or other kind of different sort of tracking protocols. So, so regardless of how your solution evolves, you can then being agnostic of those different devices and solutions means that you're catered for in the future. So I think I mentioned earlier having a sensor network overlay over your industrial SCADA network. So we're seeing those happen in certain scenarios. So for that case, it might have started by connecting via OPC-UA, and then you work out, well, hey, you've got these small temperature sensors or vibration sensors. You might want to incorporate those in because you get huge benefits of having this, let's say, less accurate information, but it's accurate enough to give you some guidance of actually what's happening on the process, which can improve insight and therefore preventive maintenance, etc., etc. So having that connection to actually connect anything, just with a bit of configuration, is very useful. So yeah, I hope that answers the question.
Yeah, it's a good start. I'll just ask you another one actually to relate to that. How can you provide some examples of device management process automation? So it's kind of like related to that first question, but might be useful just to extend that a little bit further.
So in the case where you have, well, let's take that's a full probably use case. So you have a industrial air compressor, like during sort of 2020 and 2021, a lot of these air compressors are used in hospitals, and you can't actually gain access because of the COVID regulations and other things. The same applies for other installations like factories and military installations, but the most public ones actually related to hospitals. So for that circumstance, you may get some alerts and alarms created by the machine itself. So some things logged to be a temperature overload on the machine. And then when you have that, you can actually then create some automation processes that recognize that that's being created at this point in time, plus also there may be some preceding errors or a trend that's come up. And then you actually be able to take a preemptive trigger to a field services platform to say, hey, something's happening, which then starts that process working. So not only have you triggered the field services team to be aware, they can then actually start their scheduling process to gain access. And also you may have actually tried, so before that, you may have actually tried to resolve the fault yourself. So kind of a complete closed loop, maybe it's kind of software update or something similar, configuration change. Plus also, then when the field services team gets there, they also have insight of what was the issue, what's the fault, what are possible resolutions, maybe even a link through to the user manual or some sort of guide to see how they're working. So that kind of very much kind of follows that flow. Another one, just another sort of quick one. So kind of I mentioned the elevators before. So elevators are great, yeah. So it kind of takes people up and down. However, we're talking about the connectivity. The connectivity at the top of the elevator typically is a whole lot better than the connectivity in the basement, which means that when you do software updates on that infrastructure, you need to anticipate that the software update may have complications if the elevator's in the bottom or goes to the bottom. So having processes that you can roll out a software update to a group, well, first of all, a group or the device type of different devices, and when those that fail, those automatically go back into a review process to see what the issue was. If it's possible to run it again, then you run it again and actually make it work. Once again, it's having an understanding what the cause of the issue means that you can determine whether it's worthwhile trying again, because it could be an issue that would require that lift to kind of move to the upper decks, let's say, to make it work, rather than actually just leave it on the lower deck. So having that whole process means you can basically have kind of one click to make things work. But for some of our customers, they found that using Cumulocity IoT has actually meant that they need kind of 75% operations effort in actually running those processes.
Great.
Great. But
okay.
So there's one thing, many things I kind of love about the research, Robin. But one thing that kind of comes back to that's actually related to so the respondent stated that users usually would like to have a simple system that they can easily manage. It kind of sort of relates back to that previous one. So what was the general theme regarding that?
Well, yeah, so there is a tremendous growing need, I think, for users to see simple system that's easily managed. We've gone through the stage of expecting users to understand the technology and to stick it all together and to make it work. And that's actually why the market has grown, perhaps not as quickly, into large systems as we would anticipate. So one of the sort of signs of maturity of the market, if you like, are then these systems need to be simple to use. They need to be simple to put together, and so on. But at the same time, IoT is complex, and if anything, making it more part of operations generally is going to make it more complex still, and making it international as an international solution makes it more complex still. So we need to hide the complexity. It's a bit like you know, ducks on a lake. You know, they seem very serene on the top, but they're paddling like hell underneath. And I think there's a lot that suppliers need to do to make it much easier and more serene, if you like, for the users, whilst the company is battling along underneath. And I think that's a fairly general theme. So, although it was one of our respondents in particular that hit upon that's certainly a theme that we're coming across in our surveys really quite often now. So I've got a final question for you, actually, which is, can AI ML be incorporated into device management? So you'd have seen that one of the questions that we asked was about use of AI in the future, and we think that it's becoming increasingly important. But I think your perception on device management and its use in device management would be quite interesting.
Yeah, so I'll take do a short answer, because I know we've got a couple of questions and I'm so keen to come through those too.
Yeah,
so
right.
I suppose the short answer would be yes. So can be used in device management. So we ran a workshop we did with the team on thinedge.io, which is the open source cloud agnostic device framework for lightweight devices, where we showed how ML can be used to detect security anomalies. So when you actually approaching or connecting to a device, or device is connecting, you could use that. Obviously, that requires that example requires a level of training to actually understand what is normal before you can actually work out what is abnormal. So that's one immediate case.
Okay.
But like I said, I think there's sort of that's a good topic to go into. But I'm keen to get to some of the questions. So if I
yeah, that's fine. Yeah. Okay. All right. Fair enough.
I hand over to JP.
Perfect. Well, thank you very much. Very insightful chat between two of you. Now, just before we go head over to our Q&A section, we've had a few of our audience members asking about handouts. I just wanted to advise that these will be sent to you all individually via email after the program has concluded. Now, with that being said, we'll move over to questions. So we've got quite a few that have come in. I think this one would be best for you, Robin. Now, I'm not sure if you've got this data to hand, but wondering if you had data with regards to the percentage of IoT applications for EcoStruxure building and Industry 4.0 applications.
Oh, right. Yeah. Well, I must say that when we look at the different sectors involved, we find that in the industrial sector and, funnily enough, the building sector, the building and construction sector, are the two highest usage of these types of systems that we're talking about. Upcoming is healthcare, but industrial is the largest use right now, and I can't really put a percentage on it, but certainly when we are conducting our surveys, we get more responses from the industrial sector than we do from any of the others. And then, as I say, buildings and construction tends to be second, healthcare third, transport fourth, but it tends to be in that direction. Yeah.
Beautiful, thank you very much. Now, we've talked a lot about security. And as far as cybersecurity of IoT, obviously this varies from region to region. Now, how would an organization take care of that?
Is that something that you want?
That sounds like a very big question.
That is indeed.
Yeah. So kind of going back to some of the projects been involved in. So typically, so those organizations who are reasonably mature, maybe in IT, maybe not IoT, would typically have a security, so IT cybersecurity team, which be interested in employing similar technologies that they use in the IT domain for their remote assets like laptops and phones, etc., into the IoT domain. So obviously we're talking about certificate management, deployment, encryption, linking up to PKI servers at that point in time. Those other enterprises that maybe are less mature in the cloud and IoT arena, those are the ones that are looking to take advantage of this buy and build approach. So how can they do they need to know everything that's happening in the cybersecurity? Do they need to keep informed of the EU's latest cybersecurity threat analysis? So if the next virus or attack comes out, do they need to have somebody who's actually got knowledge enough to actually understand what does that mean for them? So once again, it depends on, we talked about level of maturity, so it kind of depends on your level of maturity. So like I said, some of the customers, they've got large teams that we're working with, they're quite mature, they have an understanding, we can help them. For those other companies, they might be looking for ways to minimize the complexity in that domain by adopting the buy and build approach.
Yep.
Perfect. Thank you very much.
Yeah, I think better leave it like that because it could be a very long answer to that. There's a need for international. There's a need for end to end. There's a need for keeping up to date, as Phil is saying, with the latest threats, and I think doing all of that in house can be incredibly expensive and time consuming. So if there are opportunities to use external organizations to assist with that, then that is of great benefit, I think. And there are an increasing number of external organizations that can assist with that. Yeah.
Beautiful. Now, this next question is for Phil. And I'm not sure if you got the information to hand, but you've been asked if you would be able to comment on the deployment of IoT devices. So on average, the person that's asked the question would like to know what the investment cost per deployed IoT device is at a small deployment versus at a large deployment.
So very, very good question. So I think that's one we'd like to just have a one-to-one discussion. So obviously we have publicly available pricing for some of our smaller projects, so allow you to get started quickly. And some of the larger projects with the hundreds of thousands or millions of connected devices, obviously it's a different scale, so there's different levels of maturity involved in there. So I think stating one particular price now, or even two prices, wouldn't do you a service in giving you an indication of how it can work. And also the other thing to consider is that typically what we provide is through the buy and build approach, it's a different way to tackle the IoT projects as if you basically just took the tooling and did it yourself. So the TCO is greater, and we've got some analysis from various kind of analysts actually show the TCO is lower, and we can share that with you as well. So we'd like to take that offline to have a better view that can make a more informed decision regarding that.
Okay.
Perfect. Well, we've come to time at the end of our program here, but I just wanted to thank you both, Robin and Philip. And unfortunately, we haven't had the time to answer all the questions that have been asked, but we'll reach out to you individually to answer any outstanding questions. Now, as we close out today's program, we want to let you know that we have some great webinars lined up for 2023. Our Enterprise Grade IoT mini-series starting on the 16th of March, and we've also have some great customer and partner webinars coming up. Now, with that being said, please be sure to keep an eye out for the upcoming Beecham Research report on mass IoT, which will be out shortly. And we'll be sending out handouts via email, as mentioned, after the program concludes. Thank you very much for joining us today.
Great. Thanks very much.
Excellent. Thanks a lot.